In this video, we are going to learn about mappings in Solidity. So starting with the definition of mappings, mapping is a kind of a data structure that is used to store data in the form of key value pairs. The best way to describe mapping, I'm going to use a simple example. Take an example of clock room in railway station. So while you deposit your luggage or anything, right? So you get a token for that and your luggage is kept safely. Now let us take a simple example to demonstrate what mappings are. Like if you see, this is the clock room, okay? So and here are like different containers in it where where the luggage is being kept. So we can say like this. So you see this is identified with key. We can say any token 1 2 3 4 5 6 and similarly to the end, right? So when you deposit your luggage here, right, you get a token for that or a key for that, and the key is also placed here, right? So when you come back, so first you deposit here and you get the key. When you come back again to the clock room, you just give back the key and you get this luggage back. So you can take a similar analogy with the mappings. You place store data at a particular place, right, and you get exactly the key for that. When you just want to retrieve that data out of the mapping, and you have to use the key and you will get back the original data at that location. All right, so this is about the basic example, and you can consider it's a data structure that is efficient in retrieving the data, right? So the best way to have more explanation on that is to write a simple program, a smart contract in Ethereum, right? And we will write that smart contract in Solidity language, and we will see how we can use this mapping to to just maintain the balances of unique addresses, right? So where we will explain more about the use of mappings in Solidity. All right, so let us start. I have just written a file named as MappingsDemo.sol. so we have like predefined things, like we define first the license of the contract, right? So I kept it as unlicensed. Then we have to define the compiler we are going to use, right, for compiling this smart contract. So here I'm using any version that is above 0.8.4, right? Now we start writing contract just like in case of other programming languages. Take an example of Java. We start with writing classes with the class name. Here we write with contract followed by contract name. So here we use mapping, right? Then I am defining a mapping. So we have to take we have to just focus on this part here, because we are just demonstrating the actual use of mappings in Solidity smart contract, right? Smart contracts that are written in Solidity, right? So we just define the syntax for defining this mapping is, right, we use keyword mapping, then we define the key and the type of the key, right? It's data type of the key. So here we are just maintaining the balances of unique addresses, right? So just like you want to keep track who owns what, who owns how much of amount of any sort of like token, or it could be any ERC, right? ERC20 token. So here I'm using key data type as address, because I want to just keep track who owns how much amount of particular token. So I will use address, and so to which value it has to map. The balance are actually, right, the numbers, so we use unsigned integers, right? So we have to name this mapping, and we have to define about its accessibility or visibility. So I want to just keep it private, so I will write private, and I will say balances. Okay, now I will define two functions that will allow us to update the balance of particular address. and here we will keep it fixed. We will just update the balance of a address, that is like calling this function, right? So we will define another function that will retrieve how much balance that address has, right? So the job is to write two functions. One is to set the value in the mapping, other is to retrieve the value inside the mapping by using the key, right? So first write function set balance, and we have to set the balance inside a mapping balances, right? So to which address we have to set and how much balance we want to set it, like we should have the value here, like we say amount, and this has to be public, it could be external as well. Then what we do is that we will use balances, right? And we are using message.sender. This is basically, you know, a global variable that refers to whosoever has invoked this function, right? So if I am just calling this set balance, so my address will be as message.sender for that, right? So we are just setting the balances of this address to the amount that we have passed, right? So we have set it here. Now the job is to define the second and last function of this contract. So this function is get balance, right? Get balance, and it accepts the key now, because, and we have taken an example of a clock room here. If you see inside, like when you just deposit your luggage, you get a key, right? Or you get a token, and the token is at the luggage position as well. So now if you go back and you want to retrieve your luggage, you have to pass on this key, right? When you pass on this key, you will get back the luggage. So we have to pass on the key, and we will get back the balance of that, you know, what is the balance at that location, and that basically depends upon the key that we are going to pass. So our key is here address, right? So the data type for the key here is address. So we are passing, we can say address, right? So let's keep it this to be public, and since this does not modify any state of the blockchain, so, and it just reads only the you know, state variable, it's better to define it as a view function, because any function in the smart contract and that is deployed to the blockchain, and if it modifies the state, so it costs, right? So since this does not modify state, the previous function set balance is modifying the state. So that is like that has a cost involved in it, right, for invoking that function. But here we define it as a view just to make it more efficient, because we are just only retrieving and fetching the value, right? So it also returns the balance. So basically it returns the unsigned integer, right? So correct, what it returns is basically the balance, right? The balances of what? Balances of the address that we have defined, right? That we have defined in that we have passed inside the parameter, right? Okay, so it will define that. So if everything goes correct, this smart contract will compile and we'll have a green check. After getting green check, we will try to deploy it to, you know, browser based simulator, that's JavaScript based simulator. Right here we will not try to deploy it to any testnet or a main Ethereum, just for keeping it simple. Okay, so here I'm trying to just see there is an error, so it defines that something we have messed up, and what it could be, it is like basically we have just forget to mention function here, right? And I try to again compile it and see there is a green check here, so we are good to go, and we are ready to deploy this. So we are deploying it to you know, JavaScript based virtual machine. Basically, you know, what we are doing in Ethereum, we are just trying to, you know, deploy things to EVM, right? Ethereum virtual machine, and that could be, you know, if we are trying to run it on mainnet, then we have to just select inject web3 option here and select the main network, or we could just deploy it to any testnet. But here for this example, we are deploying it to browser based simulator, or you can say JavaScript virtual machine for keeping things very simple and very fast, right? So here we have this contract. It's named as mapping, and the actual name for the file is mappings demo, but the name of the contract is mapping. So I'm deploying here. If you look at this here, this has been deployed successfully, and we got the address of this contract. So after looking into address, we have two things here. We have get balance that accepts address, and we have set balance that accepts the amount of balance that we want to set. Now let us check. I told you initially that this only allows you to set whosoever is calling, right? So first we have this is the function, right? We have this address that is calling this function. So we want to check whether there is some balance inside this or not. So I'm just clicking get balance here, and here we go, we have 0 balance. Now I will try to set the balance as 10 and hit set balance, and again I will try to just see is their value right that has been updated. So I hit the get balance and we get the 10 here, right? So this is a basic use of Solidity mappings, right? We can say the mappings in Solidity. So these have a very great like use cases, because this has revolutionized the way we write smart contracts, the way we write ERC20 tokens, NFTs, because we have to keep track of who owns how much inside those ERC20s, or you can see ERC721s, NFTs, and all sort of new token standards, right? So this is not the only one use case. You could just keep track of anything, right? You could keep track of like the approvals, who is approved on what, right? Like suppose I don't want anyone to just call this function, I can set approval and I can use mapping for that as well, right? So this is it for this video. In next video we will see some limitations and some restrictions that we have on Solidity mappings. So we will see in that video, and thank you, and see you in the next video.